Hello and welcome back. In this video, we want to look at the limit as x goes to infinity of the square root of x plus 2 divided by the natural log of x plus 3. And before you do any work with L'Hopital's rule, we have to make sure we check the form of this limit to make sure it's an indeterminate form. Well, the square root function, if you think about it, it increases forever. It's basically a half of a parabola increasing, so it's going to be going towards infinity. Natural log function, same thing, right? It increases as you travel from left to right. So it's going to be infinity as well. Again, square root, something like this. Log, something like that. So what we have to do now is use L'Hopital's rule. Remember that is the ratio of our derivatives. So it's going to be the limit as x goes to infinity, the derivative of the top. Well, that is going to be 1/2 x plus 2 to the negative 1/2 times a 1 by the chain rule, divided by the derivative of the natural log of x plus 3. Remember, the derivative for natural log functions is always 1 over whatever is inside of them, multiplied with the derivative of what is inside of them. So next step for us is to go through and simplify this down. So it's the limit as x goes to infinity of 1 over 2 square root x plus 2 for our numerator. And we have a 1 over x plus 3 for our denominator. Of course, we don't want to work with complex fractions. Instead, we'll just multiply by the reciprocal. So this is going to be equal to the limit as x goes to infinity of a numerator with x plus 3 divided by denominator 2 square root x plus 2. If you look at this, we're still kind of at a point where we can't directly take the limit, and we're going to have to use L'Hopital's rule again. So once again, let's look at the form of this limit. And x plus 3 is a linear function with a positive slope, so that's increasing forever. Once again, we saw earlier, square root of x plus 2 goes to infinity as well. So we've got the form of infinity over infinity. So once again, time for L'Hopital's rule. So it's the limit as x goes to infinity with the derivative of the top, which is just 1. And then down below, we've got a 2 times a 1/2 x plus 2 to the negative 1/2 power times a 1 by the chain rule. We saw that derivative earlier. So that's going to be the limit as x goes to infinity of 1 over x plus 2 to the negative 1/2. Well, that's actually an exponent, so let's make that a little tiny bit smaller if we can. And we know we can now simplify that down by moving that negative exponent to the numerator. So that's going to be the limit as x goes to infinity of the square root of x plus 2. And we saw earlier that thing, we see this, our third occurrence now, is going to be going towards positive infinity. So the limit of our original function is also going to be positive infinity, using L'Hopital's rule twice. All right, and again, one of the most important takeaways of this lesson here, or this video, I should say, is always making sure you have the form 0 over 0 or infinity over infinity before you apply L'Hopital's rule. It's extremely important. You can get some really inaccurate results if you don't have that satisfied.